Hi everyone, welcome back to the channel. It's been a little while since I did a video, probably about a month. But I've been actually fortunately busy processing images, and I thought I might just go through some of the images I've been doing this year that I haven't appeared in videos. Some of the images I've done here at home, out in the observatory, and some obviously in Spain, which is currently imaging over here the squid and flying bat. And my goodness, that squid is faint. Doing 15-minute exposures, so hopefully I'll pick something up there. The unfortunate news is that my ASI 2600 Pro that was on the back of the Skywatcher stopped working. It was kind of having the odd problem every now and again where in the middle of a session or after a meridian flip it was disconnecting, and I'd have to go out and sort of unplug it and plug it back in again, and it would be fine for the rest of the night. But then about 2 weeks ago it basically would connect and then disconnect within a few seconds, and it didn't really matter what I did. I changed all the cables, I changed the power supplies, I even hooked it up to a completely different computer to see if that would make any difference, but it was the same problem. And all these cables and power supplies worked with the ASI 533 that's on the back of the Mead. So today it got picked up by DHL couriers and it's on its way back to China, to ZWO, to be repaired. So I don't know how long that's going to be, but out in the observatory, pretty much going to be sticking with the Mead until that gets back. Now, I was fortunate enough to win a set of 3nm SHO filters from Outtro here, and so now I have, these are 2-inch ones as well, so I'm going to have to get another filter wheel and some more LRGB filters if I want to use them. It was in one of the Outtro competitions, and it was for my Cosmic Bat image, so that was a really nice surprise. But it does mean I'm going to have to spend some more money to get some more filters to fill up a filter wheel and to get another filter wheel as well. And but looking forward to getting to use those, because I am really enjoying using the 3nm Outtro ones that I have on the Skywatcher, which is not functioning at the moment because the 2600's not here anymore. So look, let's flip around to the computer and I'll show you the images that I've been taking. Okay, so we're going to start with the first image, and this was taken at home here with the Skywatcher. It was a bit more of a fun project. I was sort of searching around looking for something to image using the offline sky map in Nina, and I came across this little area here of what looked like HA, and kind of reminded me a little bit like storm clouds rolling in. It didn't seem to have any sort of designation, so I wasn't really sure if it did have one. I've subsequently found out it does. But I thought, well, I'll image it anyway, and perhaps just do some HA and some RGB. I did do a bit of O3, but there wasn't much there. Now this is near the Blue Horsehead Nebula, which is over here, and Rho Ophiuchi here. If that's how you say that. I know a lot of people struggle. I'm not really sure which is the correct way to say it. But the framing sort of came up quite nicely in the Skywatcher with the 2600. Before my 2600 died, and so I went ahead and imaged that. So this was the image that I came up with. I intentionally went with a very deep red sort of stormy look, and then just with sort of a dark background and RGB stars, but I quite liked it. There was sort of some nice features in these clouds, and just reminded me of cumulonimbus cloud sort of rolling in, so I thought why not. Now as I said, I wasn't sure if this had any designation, and once I loaded up onto Astrobin, it did a plate solve and it produced this image here. So this is LBN 20 right here, And oddly, this is LBN22 is in the center of this circle, so I presume it had that name, and then within that they've got an LBN21, which is a smaller area here. But anyway, that's what these ones are called. So for this image, I'll just have a look at my details on AstroBin. It was 19 hours and 15 minutes. About 10 hours was the HA, and then the rest was just red, green, blue filters, mostly for the RGB stars. But when I actually did produce this image, I did what you do often with galaxies when you're adding HA to an image. So I added HA to the red filter to produce this image here. So as I said, fun project. You know, not the most amazing image in the world, but I quite liked it, and it just had that very sort of storm cloud look, like it was rolling in. Okay, for the next image, we're off to Spain, because I'm using the rig in southern Spain, and not sort of long after starting imaging in Spain, of course, the Northern Hemisphere went into galaxy season, which we're not so familiar with down here. We don't really have like a galaxy season. Sure, there are times when a lot of the nebula are not that imageable during certain times, but then there's always things like the LMC, the SMC, and other areas to image. So I wasn't really familiar with galaxy season, but as a result I then had to try and find a galaxy or galaxies to image. So what I ended up doing was having a look at Bode's galaxy M81 and the Cigar galaxy M82. Now at this stage I'm using over there in Spain a Stellar Mirror 90mm refractor, obviously not ideal for imaging galaxies, but for this I thought it would be okay because I did want to pick up the IFN around the background, and I didn't want to overdo the IFN. I just wanted enough in there to show it was there, but not to sort of flood it with IFN, so that it actually ended up taking out a lot of the, or obscuring the details of the galaxies, etc. So this was the framing before when I still had the focal reducer on it. So although the Stellar Mirror 90mm refractor has a 540mm focal length, with the focal reducer on it, a 0.8 times focal reducer, it was down at 432mm, which gave roughly this framing. Now later on I ended up having the focal reducer removed because I had a lot of problems with wonky stars in the corners. A lot of that ended up turning out to be tilt in the actual ASI 2600 So the camera and everything got swapped out and everything, and then they did spent a whole lot of time there, which was really good of them, to sort out the tilt and removed pretty much all of that. So now I'm imaging with a focal length of 540mm in the future, but this one was with the focal reducer on. All right, so I'll just get my head out of the way of the image so you can see it more fully. I've always loved the look of M82. This is about 12 million light years away, and it's what's known as a starburst galaxy. And the starburst activity is thought to have been triggered because of interactions with Bode's galaxy here. Now it was discovered by, I think it's Johann Bode is how you pronounce it, in 1774, so a long time ago. And it was described as a nebulous patch because back then they weren't really aware of the fact that there were other galaxies. Now this galaxy was believed to be an irregular galaxy, but as recently as 2005, a couple of spiral arms were identified when imaged, I think, in near infrared. And these arms had been previously missed because of the brightness, or the surface brightness of the galaxy, and also because we're sort of nearly on edge with our view of this galaxy. Now, in the starburst core of this galaxy, it's the Hubble telescope that found 197, which is a very specific number, young massive clusters of stars, and on average these clusters had around 200,000 solar masses. And it's said that stars are being born at sort of 10 times faster than they are in the entire Milky Way galaxy. So pretty active centre. Now if we move up to M81, Bode's galaxy, also around 12 million light years away, hence the fact that both galaxies are interacting with each other. And M81 is relatively bright, so that's why it's quite a popular target for imaging. And I love the way in these spiral arms you can see so many nice HA regions, which obviously was done with a method of adding the HA to the red filter and then producing the RGB image. Now M81, like a lot of galaxies, has a supermassive black hole at its centre, which is said to be about 70 million solar masses and about 15 times the mass of the Milky Way's central black hole, so significantly bigger. And then up here we've got NGC 3077, which is what's described as a small disrupted elliptical galaxy, and it's also interacting with the other galaxies in this group. So that was I was pleased with the result of the image here, because it did include, these three galaxies in the field of view, lots of other little smaller ones in the background here, which we can see here and here, and these ones, and of course to pick up the IFN. But as I mentioned, I didn't want to overdo the IFN because I didn't want it to overrun the other details of the galaxies in this image. Right, so still sticking with Spain, the next one I did this was the third image I did in Spain before galaxy season, and I wanted to do the Tadpole Nebula, which is here, and obviously if I sort of framed it up like this, it would have some of the Flaming Star Nebula in the corner, so I figured given the field of view I could squeeze both in, which did work out quite nicely. So we've got the Flaming Star Nebula over here and the Tadpoles here, and this was roughly the field of view. Now the image that I managed to produce here, which is this one here, where we can see the Tadpole Nebula up here and the Flaming Star Nebula here. You can see the tadpoles in here. Probably slightly more tadpole looking than our Southern Tadpole Nebula. So if you look at this image, you'd be forgiven for thinking that the Tadpole Nebula and the Flaming Star Nebula were the same distance away. They look like they're sort of joined up, but in fact the Flaming Star Nebula here is only 1500 light years away, whereas the Tadpole Nebula is about 12,000 light years away. Now this one here looks bigger than this, but because of the distances, this is actually 100 light years across, whereas this one here, the Flaming Star Nebula, is said to be 5 light years across. So obviously distances and perspective can be deceiving in this image. So within the Tadpole Nebula, we've got a sort of star cluster here called NGC 1893, which is a sort of stellar winds, I think, that's said to be coming from a lot of these stars, which are sort of carving out the look of the Tadpole Nebula. And then in here we have these structures, these clouds here, which look like little tadpoles. Now the tadpoles are sort of dense streams of dust and gas, about 10 light years long, and thought they're probably sites of star formation. Now the Flaming Star Nebula here, this is actually all obviously emission nebula, but this is actually a reflection nebula in here. So, and I really liked the sort of variation, the appearance in here, the sort of knotted and twisted look to the nebulosity in the centre there. So I think that worked out quite well, having the two in the same field of view. And as I said, looks can be deceiving. They're actually quite a few light years apart. Next on my list was the Elephant Trunk Nebula. Now obviously this is far greater than my field of view. Now when I was imaging this one, we'd taken off the focal reducer, so it was back up to the native 540mm focal length of the Stellar Mirror 90mm. Now I could have done a sort of a two panel mosaic, but I figured I really wanted to sort of capture the elephant trunk here, and then I sort of positioned it this way because it looked like more of the interesting sort of areas of nebulosity were up here rather than sort of framing it down this way. So Couldn't fit the whole thing in, but I was happy enough with that framing. This was the image I managed to come up with. So it's an SHO sort of palette, and I sort of tried to keep some of the gradations of the colours of the SHO palette. We've got the blues and through to sort of aquas and greens, and then the yellow and into the sort of deeper, more orange, and had the elephant trunk here showing up again. Some quite nice detail given the fact that it is still a fairly wider field of view for this telescope compared to a lot of images which you know, might be more sort of this kind of framing and this this zoomed in on the elephant trunk. So this nebula is about 2,400 light years away from Earth, and it contains this very dark, dense globulin here, which is known as the elephant trunk. And at the very sort of tip of the elephant trunk, you can see this very bright, illuminated area, and this is apparently being illuminated and ionized by this very bright star over here. Now, for this image, I had a total integration time of about 30 hours. I think I had 17 hours, 50 minutes of HA, again, because I was moving over to this target when the moon was out and when I'd sort of finished imaging some other targets, whether I was doing some O3 or S2 on it. There was about 3 hours of O3, so not a lot, and about 8 hours, 40 minutes of S2. So despite the fact that I couldn't get the whole nebula in, I was quite happy with this framing, and the main thing was obviously to get this part here as well as all these other little interesting areas of the nebula. So for the last image I'm just going to talk about tonight, this was done at home with the Skywatcher Esprit and the ASI 2600 MM Pro just before it died. And this is of a supernova remnant. There's not a lot of images. It's becoming a lot more popular now because a few of us have imaged it now. But the supernova remnant is called G296.5 plus 10 plus 0. And it sort of spans an area of about 1 degree, and it's in Centaurus. Now, when you look at it, if you search the location in the offline sky map, there's not much really to see here. But if you zoom in, even in this, you can see there's little wisps of nebulosity in here, little fine bits, indicating that there's something here. Now, the image, I couldn't fit the whole supernova remnant in the field of view with the Skywatcher. Now I should actually correct this to the right size because we're back with the Skywatcher. As you can see, it was even closer field of view here. So I just had to concentrate on one part of it. So my image is this here. Now, there are other parts of the supernova remnant here and further up, but they're sort of more irregular in shape, whereas this is quite a cool bit of mostly O3, but obviously there is some HA in here as well. And when I first came across this image, I actually saw one done by someone called Andrew Morell, and he had imaged this. I didn't know anything about it, and he called it the Mermaid Nebula, and I thought, you know, gosh, that really does look like a mermaid. There's the sort of head there, and then there's this tail, which is sort of a little bit extra over here, but really does look like a mermaid just sort of sitting in space, sort of gazing back at you and about to swim away. Now, the image has also been done by other people. If I'm just going to rotate this around in this direction here, has been imaged like this and has been likened to what's called, I think it's the term is betta or betta fish, B-E-T-T-A fish, otherwise known as a Siamese fighting fish because of the look of the fish here, and then they have these quite amazing tails to them, although they're very aggressive fish with each other. So it's probably more commonly referred to as the betta fish or betta fish nebula. But I don't know, I really like it as a mermaid, so I ended up using the term the Mermaid Nebula for for my image when I posted it on Astrobin. Now this is actually pretty faint, so I did do 20-minute exposures for this to try and bring this out, and I think I did a total of 45 hours and 4 minutes. So there was a combination actually of 20-minute and 10-minute exposures for the O3, and that was a total of about 27-28 hours. The HA, I did a combination of 20-minute and 10-minute exposures again, and that was about 15 hours. And then I did some RGB in the background for the stars, etc. Now I have to say that processing the Mermaid Nebula was actually quite a challenge. This is what the O3 looked like here, and we've got some, you can see the mermaid quite nicely, but there's quite a few stars around here. There's areas of nebulosity around here. There's part of the supernova remnant here, there's a bit over here, and there's bits off here. And as I said, further up here there are some other areas, but they're not quite as interesting as this area. And one of the, and I'll just show the HA. This is what the HA looks like with the stars removed. So significantly less nebula showing up there, and it just sort of really complemented the O3, and some of these fainter areas basically got sort of washed out a bit by the O3. Now the problem was trying to remove the stars and keep this nebulosity. Now I have mentioned this in another video earlier, that the problem with I'm finding with Star Exterminator is it is taking out quite a lot of sort of fine wispy areas of nebulosity that you want to keep. StarNet 2 is much kinder and tends to leave it behind, but also leaves a bit more of a mess behind.
Clean up on aisle 3!
Whereas Star Exterminator will leave a much cleaner background. So just with this, bearing this in mind, if we have a look at StarNet, you can see actually it's done quite a good job actually, as far as leaving the nebulosity untouched, and all these little fine sort of bits that could easily be removed are still here. It's just the background's a little bit messy to deal with. You can see splotches and things from where the stars were. Now if we contrast this with Star Exterminator, we have a look here, and I'm just going to zoom in on some areas. So if we just look at the tail here, we can see these long trails and that coming down here, that's all been removed. Bits that are in here, that's been removed. If we have a look at this bit, you can see there's plenty here in StarNet 2, but in Star Exterminator it's been completely removed. And the same with here, there's bits missing over here, and then if we come up to around where the head, we can see that a chunk of the head of the mermaid, this is all there, and this has been sort of removed again. So it is a significant problem with Star Exterminator, and unless you're sort of looking out for it, you can easily sort of miss the fact that you are having parts of your nebula removed. Now I did send the files of this target to Russell Croman and said, hey look, love your software, Blur Exterminator is just amazing, and Star Exterminator has been great and works fantastically on areas of nebula where you're not dealing with little fine wispy bits. But I said, we are having an issue with a lot of the fine detail being removed. And he did reply back to me, which I thought was great. I mean, I'm sure he's extremely busy with all his software development, but he came back and said that this is an issue that he is currently working on. So I'm hoping that in the near future we will have a Star Exterminator update which will, keep or preserve the nebulosity that StarNet 2 has, but give you a much sort of cleaner background, or clean background like Star Exterminator currently has, compared to what StarNet leaves behind. Now, although the supernova remnant was discovered in 1974, I think the first sort of optical image of this was by Marco Lorenzi, who posted his image on Astrobin just this year. and therefore as a result more and more people are now starting to image it. So pretty recent as far as, you know, being seen in actual amateur astrophotography images. So now that a few more of these images are turning up of this quite cool looking area of supernova remnant, I'm sure more and more will appear. Right, well that was a bit of a longer video than I expected, but well done if you've stuck it out this long. Those were some of the images that I've been doing both at home and in Spain. Mostly I'm imaging now in Spain because the weather here at home has turned to custard. Plus of course my 2600 is bust. But I do have some more images coming, some more videos that I'll make regarding those because but a lot of the images are still in the process of either collecting data or processing. And look, until next time, I hope everybody's getting lots and lots of clear skies.
It's like a sunrise warming us up, and spending all your time lifting me up. All of the things I've been worrying seem to be disappearing now, reminding me what days should be made of. Sunshine, betting on a good time. I've been chasing butterflies all afternoon. Night drives, cruising on the highlight, spending all of my time kicking with you, honey, with you. Ooh, honey, with you. Oh, we're on a coaster, we're on a cloud, hands in the stars, we're beautiful now. All of the plans I've been making seem to be figuring themselves out, letting them go, look at all we found. Sunshine, betting on a good time. I've been chasing butterflies all afternoon. Night drives, cruising on the highlight.